So we're gonna basically design a mirror today. It's gonna be like a weird shape, so everybody has their own unique design they like. You don't have to be exactly the same as mine, but I do recommend using one spline that's enclosed. Otherwise, you'll have to do p-edit and make it one line. So basically, before we get started, what I would like to do is create somewhat of a dimension of what size I'm looking to make. Most mirrors are about 24 by 24. You can go bigger, you can go smaller. So we're going to work with the 24 by 24, or you can do 30 by 30. So I'm going to do a rectangle command, D for dimension, 24 by 24. And that pretty much gives me an area to work with. Now I can go outside this area or inside this area, it doesn't matter. But using spline, I'm going to create a design with ortho off, of course, because that's the best way to use spline, with a cool, unique design. Of course, you can make it in different shapes, even to your own liking. And I created this shape. This would be my mirror. It's a really different shape. I'm not sure if I'm going to like it when it's finished, but it is an option. So I'm going to delete that reference rectangle. I have this spline set up. It's one piece. I'm going to need that to use it for a few different ways, few things. We're going to extrude this area. We're also going to use that line as a reference to sweep a channel, a metal channel that's going to protect anybody working with this mirror. Now this metal channel has to fit this mirror, which is going to be about 1/8 to 1/4 inch thick, based on your design. So we're going to create a U-shaped channel. So basically it's going to be a line going upwards using ortho. We're going to go about 1/2 inch. We're going to go across the actual thickness of the mirror, which will be 0.125, which is 1/8. And we're going to go back up 0.5. We're back down at this point. So this is basically the shape we're looking for with the sheet metal. We can have it square shaped like that, but that's really hard to come by. Usually it is rounded, easier production, because it's going to be extruded metal. So we're going to give it some fillets here at the edges. Use the fillet command. I'm going to go, let's see if I can do 1/32. Actually, that's going to be too small. So let's do this again. Radius 0.0625. So 1/16. That should close that up and create pretty much a loop around here. Now we have to use these lines to give it an offset, to give it a thickness. We're going to use an 18 gauge metal. Before I do that, I want to make sure you guys got the information correctly, so I'm going to give you guys the radius here, 0.6025, and I'm going to give you the dimension here, which is actually 0.5 total. So the mirror actually will be inside here, so what we need to do is offset these three. Actually, we have okay, so we only have 4 lines. I'm going to offset it 0.0478, which is 18 gauge steel, just about. You can never get it perfect, but that's as close as we can get. So we go offset 0.0478. We're going to offset out, like so. And we got to close the bottoms. So I'm going to put that dimension in there for you guys for the thickness. So it's 0.0478. I'm going to leave that as is, as a reference. I'm going to make a copy of this. And we have to do the p-edit option, or we can do region. We'll do both actually for this project. P-edit, which will make these separate lines one piece. We'll type in M for multiple. Select entire object. Enter. Do you want to convert these to polylines? Y for yes. We want to join it. Join, enter fuzz distance 0, 0, enter. So we have one single piece. The other way of doing it, which will be a lot faster, is if you go to your draw menu bar, you go to region, or you can type it in, select the object, and you click enter. That creates a region. But yeah, I don't know what this dot is here. It's alright. So we have both of these, which is great. What we need to do next is we need to revolve one of these items around this path. That's going to be our mirror. It's best to have this copied. So I'm going to take this mirror, I'm going to copy it over. But what I do is I copy it a specified distance. That way, once I have the mirror extruded out, I can move it back into position without a problem. So I'm going to mirror it over 50. Some number that I can remember pretty easily. So I have that copy. I'm using this design as my sweep, and this is my object I'll be sweeping. So to do that, I need to actually move it somewhat closer to the object so I can get a bit better understanding of how it's laid out to be. And what I need to do actually is revolve it around, 3D rotate actually, to make sure that it's going to be following the sweep the correct way, in which it won't sweep sideways, it will sweep the correct way. It's hard to say than show, so I'm going to show it to you in just a bit. So I'm rotating it around to a position where I think it will be following the whole path around the object or the mirror. Now, of course, your mirror will not be all the way to the end. Actually, it will be somewhat away from it because you can never get it to the edge, plus it's going to cause friction and everything. So keep it somewhat close. So you got to play around with that a little bit. And what we want to do next is use the sweep command. We go from extrude to sweep. We select the sweep path, or select object to sweep. So we select that object, click enter. Let's test it with the path as is. So I'm selecting the path, hoping my computer doesn't crash, and it creates that piece. Now if I change the visual view from 2D wire to conceptual, you guys can see that it was correctly swept around, creating a little gap in between where I can put my mirror. Now the thing with the mirror is I will have to pretty much extrude it both ways. So if I move it back, it's actually in the center of my channel. To do that, I do extrude my copy, go down 0.0625, so that's 1/16, and I'm going to do the same thing, but I'm going to do extrude faces to the top plane, and it's going to go 0.0625. So now the total thickness is 1/8, which is what I need, and it's actually been extruded from both sides, so it's extruded up and down. Now if I move that back to the original position of about 50, which I wrote, it goes right into the pocket sleeve that holds it. So that is basically the mirror. Now once you have this established, to make this actually possible to produce is there's a few things that the manufacturer will need. You can't dimension the weird spline shape for them to figure out exactly by ruler or anything how to do it. So the way they would do it is they would just take your AutoCAD drawing, take the outline of the mirror. So let's make a copy of that. Should have kept the outline, but I don't have that. It's all right. I can just explode this. Remove these parts. I think I need to explode it one more time to get back that line that I needed. Yeah. So to take that outside, I explode that and delete one of these. So I still have that line. So they would take this and they would actually use a CNC machine to cut it out in glass or in the mirror directly. Once they have that, or they might print it out, lay it under the mirror, and just cut it out using a glass cutter. The other thing is they need this information. So as you can see, I have a drawing documented what it is. The thickness, the total, let's go top view, the total size from the inside ID. So you have to specify the dimensioning that these are IDs, even though it's clearly shown. You still want to put that extra information in there just in case. And you also want the ID which is inside dimension, and OD is of course outside dimension. So we place the inside dimension because that's our critical information. We don't mind if the outside is bigger or smaller as long as our inside is to that size. And they might not be able to get that exact size, so you can specify even the tolerance. So the tolerance can be minus 0.0, so it doesn't go any smaller, but positive 0.015. And that's our tolerance. For the other part, this ID can change. It should not cause any issues with our mirror as long as we have that ID. The radius actually specifies the ID, but you might not get that, so we can actually remove that radius, make it easier for the manufacturer to make this object for us. So he knows what material, what thickness, he knows what depth we need and what width we need. We can specify the strength if needed to, the tolerance of the metal, but it may not be required. Like for this part, we don't care. The only issue we need to resolve with the mirror is how to mount it onto the wall. Probably recommend using a metal clip with a high intensive glue that would hold it up. So, or they could actually weld on a tab and connect it to the wall. That's another option. But as long as they have this information in the template detailed, specifying what thickness this mirror is, because if they go a thicker mirror, we can't go with this ID. So you gotta keep that informed, specify what it is, and that's pretty much it. So once that's complete, the manufacturer can give you a quote on how much it would cost to create this mirror. And the way they would create the channel is they would have the mirror done, and the channel would be slowly bent into that shape, following that path, which is probably harder than it looks. So that's how you do a custom mirror.